So we'll start in another 2 minutes, waiting for a few more participants to join. Good morning, everyone. I welcome everyone for this 5th webinar on the topic of sample size estimation and sampling technique in research, conducted by Journal of Indian Speech Language and Hearing Association. I take this opportunity to introduce our today's speaker, Dr. Qaiser Farooq, presently working as Scientist C at ICMR, National Institute of Research in Tribal Health, Jabalpur, Madhya Pradesh. Dr. Da is a distinguished researcher in the field of statistics and operational research, specializing in biostatistics and public health. He completed his postdoctoral research program at Incheon National University, South Korea. Following his doctoral studies at the Department of Statistics, Ramanujan School of Mathematics Science, Pondicherry University. His academic journey also includes a master's degree in statistics from the University of Kashmir, Srinagar. Prior to his current position, Dr. Das served as a biostatistical scientist at the Sher-e-Kashmir Institute of Medical Sciences in Srinagar. His remarkable contribution to the field have been recognized with several outstanding paper awards, including the prestigious Young Researcher and Young Scientist Award from Government of India in 2020. Currently, Dr. Da holds the position of Scientist C at ICMR. He has over 40 research publications in high-impact scientific journals of international repute. So, along with this, I also convey my deep gratitude for making it happening today, irrespective of your personal problems. And thank you so much for making it happening for the day. I request all the participants to have the proper usage for the next 1 hour. I hand over the platform to Dr. Dar for delivering his speech. Thank you, sir.
Okay, thank you very much, sir. So, shall we start?
Yes, sir. Sure, sir. You can share your screen, sir.
So, today topic is like a base of a research. So, I will share two quotations here. First, I want to confirm whether I am audible to all or not.
You're audible, sir.
Okay, thank you. So there is one quotation. One quotation is like the without fruits of a research is incomplete uh, without statistics. So there is like statistics is a fruit of a research, and research is a root of a statistics. You can say like that. So without knowing statistics, there is no fruit of a research. When you want to a good fruit of a research, then you should know the statistics and especially the sample size and the sampling techniques. How much study subjects are required, and how to select that study subjects. So this is very important, and we can say it is the base of the research. How much study subjects we have required, so that we will get a valid conclusion. We can make a good decision. And how to select that? How to select that, though, so that the first is coming, what should be what the sample size, and then second, how how we will collect the information, or how we will collect the responses from the sample size. So today in this topic, we will discuss only these two techniques. So first, before knowing, before estimating parameters, or before observing the behavior of the population, so we should know, we should have some fundamental concept of population. Then only we can use a proper sampling technique, a proper sample size for the population. So I will just share two questions here and hope I will get the correct answer. The first one is, when there are 10 sparrows sitting in a branch of a tree, and a shooter hit one of the sparrow with a burst gun, how many sparrows remains there? Just one participant, a voluntarily participant, to give me the answer. And another is, when there are 10 mangoes in the tree, a shooter hit one of the mango with a shot, how many mangoes remains there? Voluntarily, I want to answer of these questions. It is very simple. Very simple. So in first, the answer is, there should be there no superior remains there. And in the second, there remains maybe 10 out of 10, or out 10 out of 9, and maybe one may be destroyed. So in general, we can say, if he will properly shoot, he will get one mango. So there remains the 9 mangoes in the tree. Though the situation is the same, the action is the same, but the population is the different. In the first, there is the sparrows. In the second, there is the mango. So that should we should know the behavior of this population. And in first, just they are like actioning with the ballistic gun. Ballistic gun means which produces some noise. So in the second case, if they will hit in one mangoes, 9 remains there. So the situation is the same. So action is the same, but the population is the different. So before estimating the sample size, or before selecting a proper procedure for selecting the information from the responses from the participants, we should know have a fundamental characteristics of the population. So what is actually population? Population is defined as an aggregate of the sampling units, a group of individuals under studying called as the population, or universe. The basic aim of any study is to generalize or generally know about the population. Hence, the meaning of the population varies from study to study. It is really so. In one situation, our population remains something. In another situation, our targeted population is another sort of participants of the research. So I will just share the two examples. If one wants to know about the specific aspects in a general population of a village A, for example, the percentage of people suffering from the asthma at a given time, all the residents of the village of A at that time is our city population. So here the population are all the residents of that particular village. In the second, if one wants to know about the aspect in a given population of a village A, say for example, those those above 16 years suffering from the asthma at a given. So in this case, the each and every 60 years person of a village A is over the city population. So the population varies as per our objectives, as per our hypothesis, as per our targets also, we can say. So generally, the populations are generally finite population, a population which is countable of individuals or members, the number of students in a class, the plants in a field. So we can, the population which we can estimate, or sometimes we can say countably finite. Countably finite means we can count and we can get the final answer. Say for example, 1, 2, 3, 4. 20 students. So this is countably finite. Though in that case, that type of population is called as the finite population. And then another is infinite population. The first one is countably finite, and the second one is countably infinite. We can count, but we cannot get a final figure of the population. Say, for example, number of stars in a sky. We can count one, two, three, but we cannot say how many stars are there. So this sort of population is called as the infinite population. Then another population that is called as the real population, a population in which the members does exist in reality, does exist in the reality. Say, for example, households of a certain community, number of children in a certain village, or in a certain locality, a number of teachers in a particular school, so that their reality, in reality they are there. So this type of, or number of patients in a particular hospital, so this is called as the, this sort of population is called as the real population. Then there is another type of population called as a hypothetical population. We can just imagine, we cannot in reality the participants are not there, in reality the members are not there, but we can imagine. Say, for example, tossing of a coin. We are just saying even what will be the overpopulation, what will be the possible outcomes. What are their possible outcomes is a population, head or tail. But we are just imagining. Say, for example, tossing of throwing of a dice. So there is possible sample size, or we can say possible population is 1, 2, 3, 4, 5, 6. But reality it is not there, but possible population is there. So this sort of population is called as a hypothetical population. Then there is another type of population, homogeneous population, a population where the members or the units have similar characteristics, like, for example, identical twins, identical machines. So this sort of population is called as the homogeneous population. And in case of the homogeneous population, the population cannot be, is not possible to make a groups in the particular steady characteristic. So there is no chance to group the population. But in the heterogeneous population, we can make the group. We can say we can make the homogeneous group. Then further classification is not possible. The heterogeneous population, a population where the members or the units have a diverse characteristics. For example, population of a large city, which includes the individuals of the various ages and the socio-economic status. So these are the basic type of populations. Then population is also a type of also one another category that is called as the some targeted population. Targeted population, the which population is targeted. Say, for example, when I have when in previous slides, in first example, our target population is all residents of a village A. At that time, oh, this is our target population. But in the same population, in the second scenario, second example, our targeted population is the persons in a locality having the age more than 60. So that that is our targeted. Then longitudinal population is another type, where we are following the population, where we are observing a population for a long time. That sort of population is called as the longitudinal type of a population. And another is the cross-sectional population. Cross-sectional population is just giving a snapshot of the population. It is just at a one point of time. We are not following, we are not observing over the time. When we are just giving a snapshot of the population, then that type of population is called as the cross-sectional type of population. And accessible population, which is near to us, which is like economically access for us, that sort of population is called as the accessible population. Then population is also third category of the population is type of univariate population. Univariate population where we have no dependent or independent variables in the population. We are just giving a descriptive visualization of the population. In that population, that sort of things, that sort of population is just called as the univariate population. And when we have one dependent and one independent variable in a population, say, for example, age, age and weight. Say, for example, income and expenditure. So this type of population, this type of variables, this type of population is called as a bivariate population, because we have one independent and one dependent variable. And when we have one dependent variable and we have a lot of independent variables, that sort of population is called as the multivariate population. Say, for example, let us suppose if we want to, if we talk the health status of a particular children of a particular locality. So it is depends upon the expenditure of that family expenditure, family income, then lifestyle of the income, then accordingly their jobs like that. So they are in that situation, they have some more causal relation with that particular steady variable. So that's the sort of population is called as the multivariate population. So where is the role of the statistics? Where is the role of the sampling in a statistics or in a research, we can say? So in first, when we are starting the research, we have some idea, we have some like sometimes we can say we have some doubt, and we want to like we want to check that doubt. We have some doubt, we are saying, say for example, there is the high, there may be the association between the cancer and the smoking. So then we are to like we want to like validate, we want to check that particular statement. That statement can be checked by using the testing of significance, or we can say testing of hypothesis, which are just testing that hypothesis. So in the testing of hypothesis, so first our idea is converted in the question, some research question, and then we are converting our research questions into the hypothesis, and then we are going to check that the hypothesis, whether that hypothesis is valid or not. In case in valid, in checking the hypothesis, we are having some steps. So first, research question is converted into the this hypothesis, that is called as the setup of null hypothesis and alternative hypothesis. So then choose the statistics. Choose the statistics means which mission we can tell whether that particular hypothesis is correct or not. That mission, that function, that mission, that function is called as the sample statistics. Sample statistics is nothing. It is the function of the sample observations. So when we say we are talking, it is the function of the sample observations. So there is the role of the sampling. So without that sampling, testing hypothesis is not possible. And without the sampling, we cannot check whether our assumption of whether our hypothesis is valid or not. So if this sampling is if this sampling is estimated properly, and the information is also collected in the proper way, then only we can say finally, if there is rejection, we can say 100 in 100%. I'm sure that this is 100% wrong. Or when this sampling is chosen correctly, and the optimal sample size has estimated, then we can say in 99% sure that particular statement is true. So there is the role of the sampling. So today we will discuss on that second also. Then there are another steps in the sampling, in the testing hypothesis. Choose our level of significance. Level of significance, I will just in next slide is what is the level of significance. It is the some, say we can say level of significance is the level of tolerance. Then compute that statistics on the base of the sample observations. When we have sample observations, we can say we have the sample, and then from the sample we are selecting some significance level. Then we can estimate the compute the test statistics. That means the choose sample statistics means then we have to compute that statistics by using the sample observations. Then we have to give the decision, find the rejection region, and then take the decision whether that particular decision is following on the rejection region or following under the acceptance region. So there is the big role of sampling in testing hypothesis. So before, what is actually a statistical hypothesis? Statistical hypothesis is nothing. It is the some sort of the statement, or we can say the assumption, which may or may not be true about the population parameters. In any research study, research study, there has been a research question for the purpose of statistical analysis. This research question has to start in terms of the statistical hypothesis. Previously, I have discussed this research areas can be come up with the research question. The research questions are converting into the hypothesis, and then we are checking that hypothesis. We are testing that hypothesis, whether that hypothesis is true or not or false. So just I will give some examples of the hypothesis. This is also like an hypothesis. The mean systolic blood pressure in normal subjects of the 30 years of age in a population is equal to 120. So here we are just assuming the mean systolic blood pressure is 120. So then we have to check how much sample size we required for that particular hypothesis. We have to estimate that sample size, and then how we will collect the information, and finally compute the test statistics and use some ready-made functions, and we will get the final result. This is also sort of the assumption. We can say testing hypothesis. The mean cholesterol value in hypertension patients is greater the mean cholesterol value in the normal patients. This is also an example of the hypothesis. The percentage of baby birth with a low birth weight to the anemic women is greater than in a normal woman. So any assumption we can say it is the hypothesis. The occurrence of the lung cancer is associated with the smoking. So there is also another, the birth weight of the children are normally distributed. So these are the some examples of hypothesis. So in order to test the hypothesis, sometimes we are facing some errors. We are making some errors, we can say, on the base of the sample observations. So these errors we can say define like we have some true population, what is actual characteristics of the population, and what our findings. That findings it comes from the sample size. So say for example, either the H naught is nothing, it is just a hypothesis of no difference. We can say, say for if H naught is false and we are going to reject the H naught. So at that time, we can say we have a good decision because H naught is false. H naught false means there is difference. There is difference between the population parameters, between the two population parameters, and we are also rejecting the null hypothesis. Rejecting null hypothesis, that means we are accepting yes, there is difference. So that is called, that is also a good decision, and that decision is like in statistically we can say 1 minus alpha. 1 minus alpha is nothing, it is the 1 minus type first error. Type first error when H naught is true and we have rejected the H naught. So we have made some mistake. We are not actually making some mistake. Our finding says like that. You have to reject that null hypothesis. And when we have rejected that means that is error. So this is the type first error, and this is our type second error. And then another, when H naught is false and we are unable to reject, or we are fail to reject the H naught, again we have got some error. That sort of error is called as says second type second error, and it is denoted by the beta. And when H naught is true and we are fail to reject the H naught, that means in other words we have accepted the H naught. That is also a good decision. That decision is just 1 minus beta, and this 1 minus alpha is our confidence level. It is nothing, it is a confidence level. And 1 minus beta, it is our power of study, it is our power of sample size. So these are the two basic important things in the sampling. One is our confidence level, and second is the power of study, we can say. Say for example here another example here, another type of presentation I have given, how we will like get the concept of the type first and type second error. If the null hypothesis is really true, there means there is no difference in the population, then we are rejecting the null hypothesis, and then there is the type first error. So when we have rejected that, rejected means we have saying there is rejected means there is the difference. When there is really true means no difference is there, and we have rejected that, and that means we have accepted there is difference. So this sort of error is type second error. And when we have when our finding says do not reject the null hypothesis, that means accept the null hypothesis. Actually, when accept null hypothesis means null hypothesis means there is difference. We have accepted that there is difference. Though that type of that is also a good decision, and that decision is nothing. It is the power of confidence level. And say for example another, if the null hypothesis really false means there is difference in the populations. So and we have then there and we have rejected the H naught, then there is correct decision. That correct decision is denoted by 1 minus beta, and that 1 minus beta is nothing. It is the power of steady. And if the null hypothesis really false, and we do not reject the null hypothesis, that is also an error. That error is type second error. So there is another basic concepts in the sampling techniques, that is the power and the effect of the size. What is power and effect size in the sampling techniques? These are very important. We should have the concept of how much power we have or steady have, and what is our effect size. So say for example we have two hypotheses. In two hypotheses we have the populations. So these are the value of mu1 and mu2. That means mean at population, mean at null hypothesis, and this is the mu1. That means mean value at alternative hypothesis. Then this area, this green area, it is the graphical representation. This green area is type first error, and this whole this whole is 1 minus beta. That means it is our confidence level. And another, this area, the area area is denoted by beta, and this area is 1 minus beta, because total is 1, and when this is beta and it is 1 minus beta, and this 1 minus beta is nothing. It is the power of steady. And this is the our critical region. This is called as the critical value, threshold value. Threshold value tells us whether you have to reject the null hypothesis or accept the null hypothesis. And this what is actually affecting size? Affecting size is nothing. So what is actual effect of that particular like a particular intervention, and whether we have identified that particular effect. That means if it is null hypothesis, let us suppose this is one intervention, this is another intervention, and this is the effect size change, actual change, we can say. The effect size the effect size is a quantity to measure of the magnitude of difference or the relation that study aim to detect. It is standardized measure that indicates the strength of an effect independent of the sample, independent of the sample sample size. Independent, it is independent of the sample size. Some problem is coming. Okay. Okay, just I will share an example how we will like get the idea of this, what actually effect size is. Uh, Say for example, A large study compared two weight loss methods with 30,000 participants in a control intervention group and 30,000 participants in the experimental intervention group. So there are the two groups. In the first group, there are 13,000 participants, and in the second, same sample size in second that is called as the experimental intervention group. Now, the control group used a scientific traditional method, for weight loss. They are just using the traditional method for the weight loss. Say, for example, take the lemon tea, like that, like that. They are saying they are using that intervention for the weight loss, while the experimental group used a new A-based method. In the experimental group, the new A-based method came for the weight loss, for the weight loss. So let us suppose if when the new A-based method came, they are claiming this is very significant, very significantly used for the weight loss, and there is no side effect, like that. They are just advertising, but whether it is really there or not. So after 6 months, the mean. So now this intervention is given in the two groups. One is the control intervention group, and the second is experimental intervention group. After 6 months, the mean weight loss in kgs for the experimental intervention group, the mean was 10.6, and with the standard deviation, it was 6.7. Was measure higher than the mean loss of the control intervention group. So in the experimental intervention group, the mean weight loss is 10.6 with the standard deviation 6.7. While in the control intervention group, where the traditional medicine, mechanism is given as an intervention, there is 10.5 in the mean weight loss, and with the standard deviation is 6.7. So if we see, there is not a significance, like what there is not like that much difference in the interventions. So but when we have used the statistical tests, the p-value is 0.1. 0 point means there is significant difference. So on the base of that, we are saying the a-based method is method is very good for weight loss, because we have got the significant value. However, the difference is only 0.1 kilo between groups, is negligible, because there is 0.1 only. So, and does not really tell us about the method should so this size, this effect size tell us about that, what actually magnitude statistically says there is significance, but how much significant, that is coming by using the effect size. The effect size we can use like this formula: m1, that is the mean of the first one, minus m2, mean of the second, then pooled standard deviation, that is like n1 into sigma 1 plus n2 into s1, like that we can get. So, and then another term that is called as the effect, design effect. Design effect is also very important to aspect in the sampling theory. Design effect is just is just how, because when we are conducting a big surveys, in big surveys, we are not like in a position to collect the information from each and every participants of the population. We are conducting some surveys. So in the surveys, then we are using some cluster surveys. In cluster surveys, we are selecting a part of that population, and we are just enumerate that part. And on that part, we can say this is the characteristics of this whole population on the basis of that. Because in statistics is a big role, because it is the inferential statistics or testing hypothesis. We are just generalizing the statements. So in that case, in big surveys, we are just making the heterogeneous group. Why heterogeneous group? So that the every type of participant is coming under our sample, coming under our one group. So then if we select that particular group, then that particular group is the best representative of that population. So that design effect is nothing, just when we are making that heterogeneity in the population, heterogeneous group. In order to manage that variability, in order to manage that heterogeneity, we are using that effect, design effect. Design effect means we have to increase our like sample size by uh, some uh, some times, so that effect size, design effect, the formula is 1 plus m minus 1 into rho. What is m is nothing, it is the mean average cluster size or mean cluster size, and rho is intercorrelation coefficient. When we have these two, we will get the exact design effect size, design effect. So it is nothing, it is adjusting the increased variability in the survey estimated due to the complex design. So one case study, it will may help you uh, to understand what actually design effect is. If a study used a cluster sampling design where the students are grouped by the classes and the intra correlation coefficient rho is 0.05. Now, with an average of 13 students per class, that is cluster size is 30. Then the design effect. Then, then in order to get proper samples size, so that we will make the sure that this is actually true. So design effect, we can 1 plus 13 minus 1, 0 point something. So design effect 2.45. 2.45 means if your actual sample size is 100, then you have to multiply 2.4. That means 245 sample is your optimal size for this study, in order to say there is like some variation or some variability or some differences in the classes with respect to some study variable. Type first error, type second error. Already I have discussed the type first error, type first and type second error. It is represented, type first error is represented by alpha, and type second error is represented by beta. Then 1 minus alpha is our confidence coefficient. That is the probability of accepting H naught when H naught is true for finding an effect size. So before estimating the sample size, we have already some ready-made values, and we should know some basic variables, or we should how we will get that variable. It is all are always available in some statistical or some epidemiological, some public health books. In the last, the sort of tables are there: Z table, T table, Qaiser table. So already we should have the knowledge level of significance. What is our level of significance? Say, for example, at 0.0, that is 99% confidence interval. The confidence coefficient, the value is 2.7, 2.576. And accordingly, at 95%, it is 1.96. And 1.99, 19, it is 1.67. For it is the one tailored test. This is the for two tailored test, and also power of study. If our power of study is 80%, then we can take the Z value as 0.842. And if our power of study is 0.90, then we have to accordingly use these values, so that we will get the actual sample size. It was totally about the basic things we should know before going to collection of the sample size. The sample size is it is nothing. This is the size of the subgroup of a population that is finally covered under the study, irrespective of the target size of the sample size. The minimum sample size required. That minimum sample size required is calculated based on the design of the study and the specific objectives along with the statistical concentrations. So first, let us suppose when we are we have this we have the objectives, say for estimation of the mean, estimation of the mean, average systolic blood pressure. So in that case, the formula is like that. It is Z 1 minus alpha by 2 square S square divided by D square. So first we should know the mean value of the group, that is denoted by X, and then expected standard deviation of that particular group. If we have these values, at least we have 1, 2, 3, 4 values. So this is already depends upon your statistical that is the absolute error, that is margin of error when 5% of error, margin of error. So in that case, that means tolerable, the margin of error is nothing, it is a tolerable limit, how much you tolerate the error in the study. So say for generally we are making 0.05, that means we are 90% confidence. So acceptable error may be 0.05. Then first you should go for the literature review and find the value, and know about the average value of this study population, of the statistical characteristics and the study deviation. Then we can use the simple formula and we will get the sample size for the estimation of the mean. Say for example, a case study to estimate the hemoglobin level among the pregnant women of their community. It was expected that the mean and the standard deviation of the hemoglobin in the pregnant women from considered community were about 10.3 and 2.5 respectively. So our mean is 10.5. So here is one question is there. Question is how we will get this mean and the standard deviation. Mean and standard deviation, there is two fundamental rules to get the previous results for the sample size. Some some pre-requirements for the sample size. So we have to go through the literature review. Literature review tells us these credentials, these results, these figures. Then only we can estimate the sample size. So without information, these two information, we cannot calculate the sample size. So first we should have the knowledge what is our average and what is the standard deviation of that particular study characteristic of the population. Then after we can estimate the sample size. What happens sometimes, some students, whether they are doing PhD, whether just without knowing the population, we need a sample size. What should be our sample size? Without then all the time is what you want actually. Sir, well, actually we want to like estimate the prevalence. What is your p value? Sir, what is the p value? P value is nothing. You have to go through the literature review. Sometimes really it is not happen. Sometimes the review is not supporting you. That means there is no study like that in the literature previously published. So in that case, you have to go through the pilot study. You have to conduct the pilot study and estimate these values. A pilot study is nothing. You have to conduct the same sort of study in the smaller version, in the smaller group. Mm, Smaller group, 20, 30, whatever, and then you have to estimate these two values. Then after you can get the optimal sample size. Say in that case, it is 10.3 and standard deviation is 2.5. Then add 5% level of significance, that 0.0, that alpha is 0.00, and reliable, and your margin of error is 10%. Then how many pregnant women from the community should be stated for true this statement, whether that statement is true, for testing that statement, whether that statement is true or not. So here mean is 10.3 and the standard deviation is 2.3. Then Z value is already it is the ready-made value. It is already given by the statisticians. Z value is 1.996, and Your D is 1.03 by estimating these. So therefore, the required sample size, you have to put these value in this formula, you will get the sample size. This is the minimum sample size, that is 90. At least you have to take the 90 women in order to test this particular statement or particular hypothesis. Then there is another situation that is called as the comparison of the two means. Comparison, when you are going to compare the two means, whether they have the significant difference or not. So your pre-requirement values is expected mean of the variable in the first group, then expected mean of the variable in the second group. So x1 bar, x2 bar, then accordingly the standard deviation of the first group and the standard deviation of the second group. Then these are the ready-made values. When you have the knowledge, you will get the information of these four values, and you have just to put the values here, and you will get the sample size for comparison of the two means. So here I have given a case study. A study has seen the effect of the iron supplement for a specific period on the hemoglobin level among the pregnant women of a community has carried out. Under the preliminary studies as of reported in the literature, it was observed that the standard deviation of the hemoglobin in the pregnant women from a similar community with intervention was with intervention 2.5, that means 2.5 mg deciliter. Without intervention, it is 3.4 uh, 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 3 grams deciliter. If alpha is 0.05 and beta is 0.02, then how many pregnant women from each group should be studied if one wants to detect the differences of the differences is 2.0 of the hemoglobin group. So there is nothing, you have information, that means you have x1 information, x1 is there, that is difference is x1 minus x2, that is 2.0, and S1 value is given, S2 value is given, and the Z values are also given. Power of steady is 80%. Here are one more thing I want to discuss. When we are comparing the things, whether you are comparing to prevalences, whether you are comparing to means, huh? In that case, you are using the power of steady. Power of steady tells you whether that particular difference or particular significance, we can say, or that particular variability is because of that particular treatment or not. So that is it is telling that if it is like says there is significance and our power of steady is 80%. So it will tell you 80% chance is there. It is because that in this example, the variation in variation is because of the iron supplement. So it is effective when 80% chance. That means 20% chance means this variation is because of some other factors. We can say some other natural factors are there. But 80% chance is this significance is because by the iron supplement. So when we are putting these values in this formula, and you will get the proper sample size. Here, our proper sample size is 26. So from each group, you have to collect at least 26 patients from the population. Then same way, when you are going to estimate the average prevalence, you are going to estimate the prevalence. We can say prevalence or proportion. That is the in that case, you have to use this formula, that is Z1 minus alpha square P into 1 minus P. P is you have to go through for the P value, you have to go through the literature review or conduct the conduct the pilot study, you will get the P value. So for that, first the expected prevalence of an event in a study group should given. Then only you can get the sample size, and then expected error, and 1 minus P is nothing. That is sometimes says Q. So when you have P value, you will get the sample size for the prevalence or proportion. Just I have just one case study. A current prevalence of the malaria in a community is expected around 40%. Hence, to estimate the current prevalence of the malaria in that community. How many persons should be included in the study at 5% level of significance, and margin of error is 10%. So how many how much should be over the sample size? And we can put these values like we have already here 40%. That means p value is 0.4, 0.4, and z value is 1.96. Then that means 1.96 square into 0.4 into 1 minus 0.4 divide by 10, and you will get a divide by 0.10 square, you will get the answer. Very easy. So there is minimum 92 people should be included in the study. Then only we can say that particular prevalence is valid. Then same way when we are comparing the two prevalence, you have to use this formula. Z1 minus alpha and Z1 minus beta. Beta is nothing. It is the power of 1 minus beta is nothing. It is the power of steady. So power of whenever you want to compare the two things, you have to use the power of steady. Power of test, we can say power of statistics or power of test. So this is the formula. P1 is nothing expected prevalence of the first group, and P2 is nothing expected prevalence of the second group. So how we will get the P1 and P2 values? You have same way, you have to go through the literature review or conduct the pilot study. So after getting the P1, P2 values, then you can use the Z value at 95% or 99% or 93%, whatever. The values are there. Usually we are using the 95%, and you will get the actual sample size of that particular study. So further case study I have uh, put here. Children attending in the public school has expected a dental problem. Among them, 80%. In another group of the children attending in the government or municipality corporation schools, it is 70% are expected to have this problem. So some dental problem are going to whether in two classes of the schools. How many children should be included from the each group to determine whether there is difference in significance, whether there is difference or not at 5% level of significance if we wishes to 80% chance of detecting that particular variability. If there is difference, we are sure that that difference is 80%. So here we have the P1 values, that means 80%. P1 is 80%, that means 0.8, and P2 is 70%, that means 0.7. Then P is nothing. It is P1 plus P2 divided by 2. That means average of two prevalences. 0.8 plus 0.7 divided by 2. It is 0.75. Then Z values already, it is ready-made values, and the power of study is at 80%. It is here, it is 0.842. And we have put these values, you will get the answer. Answer is the 294. This is what the required minimum sample size from each group. So at least from the children attending in the public school, you have to your sample size should be 294 minimum, 294, and from the municipality or government schools, same sample size, so that then only you can say that particular difference is there. So this is all about the this was all about like sample size. In case of the survey, this cluster surveys for prevalences, for estimating the prevalence of the cluster. So in that case, it is that 1 minus alpha by 2 square p into 1 minus p divided by d square into design effect, because now we have to grouping the whole population. Say for example, if when just I will share, say for example, expected this immunization program of the country. So whether we are whether when we are, let us suppose we want to check what is the actual coverage of that prevalence, actual coverage of the vaccination of our country. So first our country, then we will divide that country into the status, because we have the status. So this is our clusters. Then from that clusters we are going to make a cluster and collect the sample size from one cluster or complete enumerated cluster and generalize that in the whole whole country. But that particular cluster should be the best representative of the whole country. So that means the whole diverse classification or whole diverse variation of our country should lie in that group, because for that purpose only, for that we have to cluster a heterogeneity. Whenever we make the heterogeneity, then only the all sort of peoples coming under that particular group. So in order to make that complexity, we are using then design of effect. So here we have estimated the sample size 192. So for that purpose, we should have at least 92 uh, 193 participants. So from the whole survey. So 7 children from per cluster. So then there are other another sort of situations when you are going to use the odds ratios, and this is just a formula. Nothing, you have to first should your information P1 and P2, and then only you can get the these are the some case studies we have collected here. And there then estimation of the sample size in other cases like testing of significance for the odds ratio, then relative risks with the significant relative precisions, testing of significance for the relative risks. Then there is some non-inferiority of two means, then the non-inferiority trials for the proportion, comparison of the. So these are the formulas. It is very easy. It is available everywhere. It is it is now available in our mobile phones also, and some softwares for estimation of the sample size. One is one of the best. I cannot say one of the best software, that is the G Power, and another is APU Info is another software. Then by use of the Stata and R programming, we can make the package and we can estimate the sample size. SAS also can use for the estimation of the sample size. Then PASS and some online sample calculators are also available for estimation the sample size. This was all about the sample size. Now the sampling. What actually sampling is? Sampling is after getting the sample size. Let us suppose you have need of 13 participants for the testing the particular characteristics of the population. Then you have to make the how you will get that 30 from the population. For that the sampling. Sampling is nothing. It is the process of drawing a representative sample from the populations. So process means to get the appropriate representative sample from the population. So then there are some like basic terminology: sample frame, a list of all sampling units with identification address in the population is known as the sampling frame. Then sampling fraction is nothing. It is a proportion of the sample size chosen to the population is known as the sampling fraction. Say for example, if we have to select a sample of size 100 out of the population from 500, you will get the sample fraction, that is 100 divided by 500, that is 1:5, that is 20% is our fraction. This is like some terminology: sample size, sample frame, sample friction. Then sampling. There are the two sort of sampling. One is called as the objective sampling and another is the subjective sampling. Objective sampling is when there is some rule assigned in order to select a population, in order to select a participants from the population. There is some rule. That sort of population, that sort of sampling is known as the objective sampling. And when there is no rule, we can say there is when there is no rule in order to select a unit from the population as a sample. that sort of sampling is called as the subjective sampling. So statistics is always dealing with objective sampling. So objective sampling means there is some rule. Then if in objective sampling, then there is probability and non-probability sampling. Probability sampling is when there is rule and when there is some fixed rule for collecting a sample unit from a population, and that selection process is assigned with some probability. That sort of that sort of process, sort of process of sampling called as the probability sampling. And when there is no probability associated with that sampling unit, it is called as a non-probability sampling technique. So in case of non-probability sampling techniques, there are some different different types of techniques in non-probability sampling. One is voluntarily. Voluntarily, we are saying we are willing to include in the study. That is called as a voluntarily. That convenience sampling. These are the all non-probability, because non-probability sampling techniques. Then conventional sampling is also one of the another sort of non-probability sampling technique, and quota sampling, and then there is judgment sampling and snowball sampling. There are some situations, say for example, when we are collecting the only 100 participants for this to test some assumption or test some research question. Then that sort of population sampling is called as a quota sampling. And the snowball sampling is another sort of sampling technique. Say for example, snowball sampling has a nature. It is first selecting a sampling unit and then refer that sample and make the reference for collecting the other samples. Say for example, let us suppose it has a snowball nature. In snowball nature means you have first unit of the sample, and then that first unit give the information of other samples. That is called the referencing. First the information of the first participants, and that participants is only give the references of the other. Say for example, let us suppose when you are going to check regarding the drug users of any community. So first you have to identify at least one. Let us suppose you are going saying some psychological, whether they have psychological depression, what is the reason why they are doing the drugs. So first you have to identify and give some questions. Why you are using this? What is the reason behind this? What is the expansion is behind this? So when you will get the information, and finally you can say him any other guy or any other person is using the drugs in a community, he can tell, he knows, he can say yes, that another. Then that sort of process is called as the snowball sampling techniques. Because I think time is running, and I have also some work, because my daughter is admitted in the hospital, so I have to leave now. But anyway, then there is another sort of in probability sampling. In probability sampling is simple random sampling, stratified random sampling, then systematic random sampling, cluster random sampling, then PPS sampling, and multi-stage sampling is another technique, and multi-phase sampling. Simple random sampling when your population is homogeneous, and each population unit has an equal chance being selected as a sample. That sort of sort of sampling technique is called as the simple random sampling. And when your population is not homogeneous, then there is some sort of problem. Then we are using the stratified random sampling. Stratified random sampling is nothing. We are making the homogeneous groups. Then from the homogeneous groups, we are selecting the randomly some participants, some sampling units. That sort of process is called as the stratified random sampling. Then systematic random sampling. Systematic random sampling, when you have infinite, that means your sampling frame is not available. Then we are making some systematic nature. After five, you can select the one. Then 5, then 10th use the second sampling unit, 15th is the third sampling unit. That systematic nature, first you have to select the first one randomly. That means when you have 10 sample units, out of 10 you have select one. Say for example, it is the third coming. Then you have to make the same sampling interval. After 3, then 6, then 9, you will get the sample size. Then cluster sampling. Cluster sampling means when you have a large population, you are just making the clusters and then use the random sampling between within the cluster, and that sort of sampling is called as the cluster sampling. Then PPS sampling, because some type in cluster sampling, we are using 3 clusters, and we cannot use the same sort of same number of participants from the each cluster. It is depends upon their population. Say for example, the 3 clusters has selected. The population of the first cluster is 1,000. Population of second cluster is 10,000. Population of third cluster is 1 lakh. So on the base of the proportion, we have to select the sample size. That sort of sampling technique is called as the proportional PPS sampling. huh? Probability proportional sampling. Then multi-stage sampling is another sort of sampling. Multi-stage is like in cluster sampling. You are just making the stages. First country in status, then status in the blocks, then blocks in the, say for example, blocks in the villages. So these are the stages of the sampling. And multi-phases means, multi-phase is something different. Some difference means first you have to identify the prevalence. Let us suppose in what is the complications in the sickle cell patient. What may be the future complication of the sickle cell patients. First, you have to find the sickle cell patients cohort group. When you have to find that so in first, let us suppose you are selecting 10,000. Then you have got that group. From that group, you can use the multi-stage, multi-phase sampling. For the second phase, you can select the 500 or 300 in order to identify what will be the future complications of the in the sickle cell patients. So I think today it is enough. So thank you very much for your mm, listening. Hello.
Yes, sir. Does anyone have questions? Please post it in the chat box. Dr. Darsir, have a
Yes.
question from one of the participants.
Okay.
I'll read it out. Okay. Uh, his question is, he has a sample, I mean, he wants a doubt in
I think I have
sample.
got one in my research area. The
Yes, sir.
subjective performance of the developed list should have a similar score. That is the statistical analysis for subjective performance across the list result is no significant difference. In this case, which which sampling formula or method should I use it? So wait a minute. Subject to performance to develop to similar support. Okay. Actually, sir, as per, I think he has got, say, for example, the same score, sort of same score, the which sampling. But the first, what actually, whether he wants us to make estimate some prevalence or whether he wants us to make some average or risk factors, but here it is not mentioned. But if possible, you just give the mail ID. I will like clear these questions in future also. I am not getting proper idea what actually he or she wants here.
Sure, sir. Sure, sir. So if we have one more doubt, there's one more doubt from Revati.
Okay, I will. Okay.
This will be the
Could
last doubt, sir. Later, we will
yeah.
be taking up the
Could
questions and
you
be sending
please
it
give
through
me the
emails.
example of the study where in we have to report the design effect in the results? Yeah, actually, he or she is talking about the design effect.
Yes, sir.
Design effect. I have already discussed when you are like using the cluster sampling. Cluster sampling, in cluster sampling, what we are doing, we are making a small, easy situation making in complex form. Complex form means we are making the heterogeneous group. In order to make the heterogeneity, we have to use that design effect. Most of times we are using design of effect in the cluster survey, some cluster surveys, we are using design effect. Design effect, minimum we are making like 1.5, and maximum it may be 3 also. It may be 3 also, but we can use the design effect in cluster sampling where we are making some groups. Is there any
I think,
ASCTD is
sir, will
only?
stop taking the doubts. And everyone,
No, no, sir. Actually, it is very important for me also what actually audience wants. So you just copy paste in my mail. I will reply one by one all these questions.
sure, sir, definitely. So we have given our official JISHA email ID. So if anyone has any kind of doubt, please post your doubts to that email. So we'll be answering to you personally.
Actually, the sampling methods or sample size, it is not like the 1 hour or 2 hour session. It needs lot of discussion, lot of time, especially lot of discussion. With the discussion, we will get the idea actually how much sample size we should have. So in within 1 hour, it is not possible to cover all these things. Even in last slides, we have not discussed all these properly. But in whenever you have any need of assistance, you have need of my help, I will always available, and I will always try to make some easy, clearly I understand what you actually want.
Sure, sir. Sure, sir.
Thank you very much, sir. Thank you.
Thank you so
I
much, sir.
also thanks to Madam.
Yes, sir.
Uh, so
So,
it was very hot. This time I am not able to say something because it was not managing the situations. I am just morning 9:30 I came home, and I
so you're not audible, sir.
hospital because I have received only three calls continuously.
Okay, okay, fine, fine, sir. We'll just conclude the session. Okay. Uh, Thank you, sir. Thank you for your wonderful insight regarding the sample size estimation. So I would like to thank everyone. So I take this opportunity to thank Dr. Dasar for spending your spatium in the difficult time, in the difficult situation, and giving us a wonderful insight regarding the sample size estimation. I also thank Dr. Pinki Singh, the Chief Editor, JISHA, for organizing this event. I also thank ISHA President and ISHA Committee, Secretary, and office staff, Ms. Shweta, for all the technical support. At last, I would like to thank all the participants for being here. Thank you so much. Have a nice time. If you have any doubts, please post your doubts to the given email ID in the chat box. We will be answering it to you personally. And please fill the feedback form without failing for the further purpose. Thank you so much. Have a nice day.